Hello guys, welcome to my channel. Today we will be talking about the Numpy arrays and we'll see the main differences between Numpy arrays and conventional Python lists. So let's get started. Here you can see the Numpy arrays containing integers and floating point numbers. Of course, there are arrays containing different data types like objects, imaginary numbers, and so on. Here you see different dimensional arrays like one-dimensional array, two or three-dimensional arrays. Like three-dimensional array, the block of the two-dimensional arrays. Here there is a concept of axis, but we'll not talk about the axis in this video. It's a topic of another video, and we will talk about the axis, their usage in different operations like concatenation, finding the sum, maximum, element, standard deviation over the axis. Here you see the conventional Python list. In the first picture you see the list of the characters. The list contains 14 elements and the indexing starts from 0 and ends at 13. If you want to find the last element of the list, you can use the index -1. If you go to the end of the list, indexing starts from -1, -2, -3, and so on. In the Python list, you can use different data types, like one list containing integers, floating points, strings, then array of different elements, and so on. Let's see the differences between Numpy arrays and Python lists. The first one, the dynamic. Python lists are dynamic, but Numpy arrays are fixed. Like as I said earlier, in Python lists you can use different data types like strings, integers, floatings, and so on. But when you create Numpy array, you usually set the data type as constant. Integers 32, 16, 40, 64, or float 16, and so on. Python lists are used for general purpose. It can be used in different fields, but Numpy arrays are usually used for mathematical and scientific purposes. In computations, Numpy arrays are very efficient and fast. And in terms of speed, Python lists are much slower than the Numpy arrays, and we'll see why. And memory, the Python lists take more memory than the Numpy array, and also we'll see why. So let's see how Python lists are stored in memory. In this case, you see the Python list containing all the elements as integers, but they can be integers, string, floating, and so on. But the disadvantage of a list is that in each section you have to store the data, you have to store its storage, or you can store the pointer of the second element. Like in the first one, you store the data, you store its data type, and you can store the location of the second element. When you reach the first element, you can use this location of the second element. You can go to the second one, you can go to the third one, fourth, and fifth one. Of course, if the elements are located like this, it will be time consuming to find the elements if your list containing more than like 1,000, 100,000 elements. That's why Python lists take more memory. But here Numpy arrays don't do that, because in the first element you can store the data, and the elements inside the array are located in contiguous memory. like if the location of the first element is 1000, the second one will be plus 4 bits, like 1 byte. 1004, 1008, 1012, 1016. And you will not need to store the location of the next element. You don't need to store the data type each time. That's why the NumPy arrays are easier to access the elements, to store the data and data types. Here you can see the NumPy arrays attributes and functionality. NumPy arrays the flags, you can see the shape, you can look for the shape. If it's two-dimensional, it will give like 3 to 4 and so on. Base, data, like dimensions, size, item size. You can see how many bytes of data it takes for your array, item size, and so on. So that's the end of the video. I hope this was helpful for you. If you like the video, please press the like button and follow the channel.